In this last part of Module 11, I want to just summarize what we know about curved arrows and then give you some examples of the kinds of problems you might be asked to do with curved arrows. So, as a reminder, what curved arrows show, we can have an arrow that starts at a lone pair and goes to an atom. That shows that we're forming a bond. That shows that that lone pair is getting shared. And that shows that we are forming a new bond. Remember, it never shows transfer of electrons. So here, this lone pair is going to become a shared pair. So my nitrogen is now going to have a shared pair with boron in this case. Boron is still bonded to 3 hydrogens. Nitrogen is still bonded to 3 hydrogens. And then I think about formal charges. Nitrogen had this lone pair all to itself, and now it's sharing. So it's ending up with a positive formal charge. Boron only had 3 pairs of electrons. Now it has a fourth that's shared with it. It ends up with a negative formal charge. So we can use curved arrows to show forming of a bond. We can show an arrow from a bond to one of the two atoms. That shows we're breaking a bond. And we're making a new lone pair on the atom where the arrow ends. So in this example here, I start my oxygen as a positive formal charge. It has one lone pair. After I do this, carbon is essentially losing an electron here, so it gets a positive formal charge. Oxygen now has 2 lone pairs, and it doesn't have a formal charge anymore. So we can use arrows to form bonds. We can use arrows to break bonds. We can show a bond moving and leaving behind one of the two atoms that it was previously shared with. So this shows, breaking a bond and forming. At the same time. Now this arrow here, actually, there's 2 different possibilities for what the product could look like. Because I know that this is going to form a new bond to hydrogen, but the arrow doesn't tell me which carbon is going to form the new bond to hydrogen. I'm going to use numbers to keep track of my carbons here. I'm going to number this one 1, 2, and 3. So I know I need to form a new bond from either carbon 2 to hydrogen or from carbon 3 to hydrogen. I don't yet know which one it's going to be. So I'll draw both possibilities. So we could be forming a new bond from carbon 3 to hydrogen. In this case, this would be my new bond to hydrogen. And that would leave a positive charge on carbon 2. Or, give myself a little more space here, I could be forming a new bond from carbon 2 to hydrogen. One, two, three. So my new bond could be from carbon 2 to hydrogen. in which case carbon-3 would end up with the positive charge. And you will learn in module 15 about how to make that prediction. So this comes up in module 15 and 16, how you would predict which of those is more likely. But that's the case where we're forming a new bond and breaking an old bond at the same time. All right, so those are the three kinds of moves of our arrows. I know I keep harping on this, but I think it's important that you don't try and use arrows to do something that they're not allowed to do. We talked last time about making predictions, and when we make predictions, it's very important that you remember we're always going from partial negative to partial positive. Why do we do that? Well, remember, arrows are showing how electrons get shared. If something has a negative charge, that is going to be the site that we're going to share from. That's where the extra electrons are. And it's going to be attracted to things that are partially positive. So as an example, let's take this these two molecules. The one on the right, since this has an overall negative charge, that's generally going to be where I share from. Is from that atom with an overall negative charge. So I'm going to consider the partial charges on my other molecule, and the partial charges on my other molecule would be nitrogen is strongest there, so it's partially negative, carbon is partially positive, and hydrogen is partially positive. So if I'm thinking about where this oxygen with a negative charge might share with, I can think of two possibilities. And those two possibilities are going to be either with the carbon or the hydrogen. So in possibility one, let me share with the carbon. And I have to break a bond. Now you probably you might already have some intuition about this. But if I share with that carbon and I have to break a bond, I could either break a bond and send electrons to nitrogen, or I could break a bond and send electrons to hydrogen. What does your instinct tell you there? Think for a moment. Who is more likely to pull electrons toward itself, nitrogen or hydrogen? All right, hopefully you came up with the answer of nitrogen, because nitrogen is more electronegative. Generally, we try and send electrons in the end toward more electronegative atoms. They're the ones that pull them more strongly. So if I do this, I would get this product. All right, that would be one possibility. The other possibility would be to share electrons with hydrogen. And if I do that, I have to break the hydrogen-carbon bond to make space. What will that give me? Well, now I'm going to have water as one product. And I'm going to have this cyanide ion as my other product. So when you're making predictions, those would be the kinds of things that you do. Look for partial positives, look for partial negatives, or even negative formal charges are a great place to start your arrows, because there are extra electrons there. And then just come up with possibilities. Again, most of the rest of an organic chemistry class is considering all the individual reaction types and the individual cases to figure out, well, which products do we end up getting. So you will get more clarification as you go further. This is a reminder for anyone who's done Module 6, but if you didn't do Module 6 and you're looking at Module 11 now, the curved arrows work within a molecule. We call this resonance. When we are sharing electrons within a molecule between lone pairs and pi bonds. But we can imagine sharing a lone pair from oxygen to carbon, moving this bond from left to right, and then breaking this bond and making a lone pair on the other oxygen. This is what we could call resonance when we're sharing within the lone pairs and the pi bonds in a molecule. So now my oxygen on the left here would only have 2 lone pairs. There'd be a double bond. My oxygen on the right would now have 3 lone pairs. And my carbon-carbon double bond has moved over to the right. So if you've done Module 6 and you've seen a bunch of examples of this, same kind of curved arrows, except Module 11 is focused on sharing electrons between molecules. So let's look at examples. Examples where you would be, one kind of problem you'd be asked to do is to look at a set of curved arrows and decide what the products look like. So when you're doing this kind of problem, there's a few things I recommend. Number one, keeping track of atoms is helpful. So I might number my atoms here, 1, 2, 3, 4, 5, so that I can keep track of them in the product. The bigger the molecule is, the more helpful numbering is. So that is a go-to technique that organic chemists use all the time, and I strongly recommend it. Number two, I want to ask myself for each arrow, like, what is it doing? Is it forming a bond? Is it breaking a bond? Or is it doing both? So I ask myself for this first arrow here, what is this doing? So this seems to be forming a bond from 5 to 4. So I know I'm going to need a new bond from carbon 5 to carbon 4. All right, I ask myself for this next arrow, what is this arrow doing? Well, this is breaking a bond from 3 to 4, but forming a bond from 2 to 3. All right, so this one is telling me that I'm moving a bond. It was from 4 to 3, but now it's going to be from 3 to 2. So now I would have an extra bond from 3 to 2. And then for my last arrow, this last arrow is breaking the bond from 2 to oxygen and making a lone pair. And you don't have to write all this out explicitly. I'm just trying to make my thought process clear. But if it helps, write it out explicitly. So now in my product, I have carbon 1, 2, 3, 4, and now there's going to be new bond to 5. And I feel like I don't like the squiggliness. Sometimes when I start writing toward the right edge of the screen, it gets hard. My hand falls off. All right. So I have 1, 2, 3, 4, and 5. I have my new bond between 4 and 5. Okay. Carbon 5 is still triple bonded to nitrogen. Carbon 2 and 3 are now going to have a double bond because I moved a bond over there. And carbon 2 still has one bond to oxygen. That oxygen now has 3 lone pairs, and it has a negative formal charge. So that would be how I draw my product. Take a moment, try this second example. All right, so again, I wrote out my thought process here. Identified that I need to form a bond either between 1 and N or 2 and N. It doesn't really matter. Those two carbons are equivalent. So whichever one I choose is going to make no difference. I'm breaking the pi bond between 1 and 2. So if I start to draw my product, I'm still going to have this 6-membered ring. 1, 2, 3, 4, 5, 6. I'm still going to have a pi bond between 5 and 6. I'm still going to have a pi bond between 3 and 4. I no longer have a pi bond between 1 and 2. Let me say I'll make my new bond from number 2 to nitrogen. All right. Now, that's taking electrons away from carbon 1. So carbon 1 now is going to have a positive formal charge. All right. I formed my bond between number 2 and nitrogen. Nitrogen still has a double bond to one of the oxygens, but now it has a single bond to the other oxygen. And if I think about lone pairs, both oxygens started with 2 lone pairs. Now the oxygen at the top still has 2 lone pairs. But the oxygen at the bottom has 3 lone pairs. And so in terms of formal charge, this oxygen is going to be negative. Nitrogen started positive, it still is positive. All right. So that's how you can be given a set of arrows, identify the bonds that are getting formed, and then draw the product that would be made. All right, let's consider the reverse kind of problem. Here, I'm shown products, and I'm asked to draw curved arrows that will actually describe what happened. Different kind of challenge, but still we can apply a lot of the same tools, the same thinking. So what I want to do here is, looking at the product, identify any new bonds, identify what bonds got broken. So my thought process steps here are going to involve: one, identify new bonds, and identify bonds that break. All right. Again, numbering is going to be helpful. So I'm going to take this and do 1, 2, 3, and 4. And now I'm guessing that this is 1, 2, 3, and 4 in the product. All right, so what bonds break? Well, I have a bond from 3 to oxygen. That I need to break. What bonds form? Well, I have a bond from carbon 4 to carbon 3. All right. So I'm breaking one bond, I'm forming one new bond. I can also notice that over here, this oxygen had 2 lone pairs. In the product, that oxygen has 3 lone pairs. All right, when I'm forming a bond, I always want to think about who had the electrons to start that formed that new bond. Who is doing the sharing? And I want to share from negative to positive. So if I'm going to form a bond from 4 to 3, then that means I want to start my arrow at this lone pair on 4 and share that with carbon 3. That's going to form the carbon 3, carbon 4 bond. And then I need to also break the carbon 3 to oxygen bond, and I need that oxygen to get an extra lone pair. So I'm going to have an arrow going from that bond to the oxygen. Essentially, anytime you're breaking a bond, that means an arrow needs to start at that bond and send those electrons somewhere. All right, so this first case, we're done. Second one. All right, I chose a tricky one here. And what's tricky about it is if I look at my product, I'm going to draw out this H2O. I'm going to fill in my lone pairs. What's tricky about this example is it seems like a hydrogen is coming out of nowhere. On the left, I only have OH. On the right, I have OH2. So I have to ask, where did that extra hydrogen come from? This is where it's helpful to remember all of our implied hydrogens. So if I go back to my starting material and draw in my implied hydrogens, there are 3 of them here on carbon 1. There are 2 of them on carbon 2, and there are 2 of them on carbon 3. If I look in the product, carbon 1 still has 3 hydrogens. Carbon 2 has 1 hydrogen. Carbon 3 has 2 hydrogens. By drawing them in explicitly, I now am able to see which bond I need to break. I need to remove a hydrogen from carbon 2. So I need to break carbon 2 to hydrogen bond. I'm also breaking the carbon 3 to bromine bond. All right. What new bonds am I forming? Well, I'm forming a new bond from oxygen to hydrogen. This bond here, that's a new bond. I also need to form a double bond from C2 to C3. All right. So now, let me think. I always want to think about electrons flowing from negative toward positive. So I have a negative charge in the OH, and I need to form a bond from that oxygen to a hydrogen. So the way to do that is going to be to share this lone pair with hydrogen. That's going to form the OH bond. I need to break the bond between carbon 2 and hydrogen. So I need to take these electrons and move them somewhere. Well, I can move them over here and share them with carbon 3, and that will do two things. It'll break the carbon 2 to H bond. It will also form the carbon 2 to carbon 3 pi bond. This one here. And then my last move is I have to break the carbon 3 to bromine bond. Well, I can do that by turning this bond into a lone pair on bromine. That's what gives bromine its negative formal charge. So I'm moving that pair onto bromine. So I now have accomplished all of my objectives. So that's an example of how you can be given reactants products and come up with curved arrows. On the Skill Builder, you'll get lots of practice with this, but please let me know what questions come up for you. Let's do one last one, and this is where I've put together 3 reaction steps. And I want you to come up with the curved arrows that would complete each step in this reaction sequence. So you'll notice the product of step 1 goes into step 2. The product of step 2 goes into step 3. So this would be a reaction sequence that could occur within a flask in the lab. So take a minute, try and break this down, make your predictions, draw your arrows. And then after you've done that, come back. All right, in this first step, I see that I need to break a CH bond. And I see that I need to form an OH bond. All right. Well, oxygen has the lone pair to share. So what I'm going to do is I'm going to have oxygen share that lone pair. And when I do that, I'm going to break this CH bond and make it a lone pair on carbon. In the second step, all I see is that I am breaking a CBr bond. I'm not forming any new bonds. I'm just breaking that bond. So that's pretty simple. I'm going to take it and I'm going to turn it into a lone pair. Notice bromine started with 3 lone pairs. It ended with 4. So one of those came from that bond. So in step 2, I just broke a CBr bond. All right, step 3. Now this gets interesting. If I label these 1, 2, and 3, I need to form a carbon 3 to carbon 1 bond I also need to form a carbon 3 to carbon 2 bond. And I'm breaking the C1 to C2 pi bond. Well, how am I going to do this? I see that carbon 3 has a lone pair. So I can form a bond from carbon 3 to either carbon 1 or 2 by sharing that lone pair. So let me do that. I'm going to share this lone pair with carbon 1. That will form the C3 to C1 bond. Now I have two things left. I need to break the carbon 1 to carbon 2 pi bond. So that means I'm going to have an arrow that starts at that bond. I can use that to go and share with carbon 3 to make the carbon 3 to 2 bond. So here we have two arrows, and that leads to these products. This pair of electrons came from the carbon 3 lone pair. This pair of electrons came from the carbon 1 to 2 pi bond. So these things can look really confusing at first. That's why I say you should go through, just identify bonds that you're breaking and forming. It's really just being observant. And that can lead you to identifying where electrons need to get shared, where bonds need to get broken. Again, you'll practice this on the Skill Builder and let me know what questions come up for you.